Okay. Right. So today's topic is mechanical properties of materials. Last class lo we have discussed about how the ESET exam is going to be, what are the questions or what is the syllabus of ESET, right? And then we have seen what is the composition, how many marks each subject is going to carry, how many marks strength of materials is going to carry, mechanics, and then how many marks theory of structures is going to carry, how many marks R.C.E is going to carry, right? Strength of materials and mechanics are going to carry around 40 marks. They're going to carry around 40 marks. R.C.E 20 marks, and then you have surveying 15 marks, and then you have hydraulics 15 marks, and then irrigation for 10 marks. So this is the splitting. Can you all see the screen?
Yes, sir. Yes, sir.
Okay. So this is the splitting. ఇందులో మనం వీఆర్ స్టార్టింగ్ విత్ స్ట్రెంగ్త్ ఆఫ్ మెటీరియల్స్ అండ్ థియరీ ఆఫ్ స్ట్రక్చర్స్ అండ్ అ బ్రీఫ్ beginning about mechanics also. Okay, some people are joining. Let me just accept them. Okay, so because mechanics of solids and theory of structures is going to carry 40 marks, so let's begin with mechanics of solids and theory of structures. So today we are going to discuss about mechanical properties of materials. What is this mechanical properties of materials, and what are those mechanical properties? How do you find out those properties? What is the experiment, or how are you going to calculate? How are you going to calculate those values? All that we are going to see in today's class about mechanical properties of materials. I hope everybody got a clear cut idea about how was the CSET going to be, how was the pattern of the exam, right? All of you understood what is the mode of preparation, how you have to prepare. Okay, still some more people are joining. Right. What do you understand by mechanical properties of materials? First we will start by what you understand by the mechanical properties of materials. So we are civil engineers, we are doctors of structures, we are nothing but doctors of structures, right? So why are we called as doctors of structures? Because we are doing diagnosis to the structure. We are doing diagnosis to the structure. That means ఏం చేస్తున్నాం మనం ఇక్కడ స్ట్రక్చర్కి వచ్చే పెయిన్ ఏంటో మనం తెలుసుకుంటున్నాం. వీఆర్ ఫైండింగ్ అవుట్ బికాస్ a human, let us compare a structure with a human. Okay, oka human ki you have different properties. Every individual has a different characteristics. Yes or no? Different characteristics. Some people are
Yes, sir.
some people have characteristics like some people are గొడవ జరిగినప్పుడు పీస్ఫుల్గా ఉంటారు, కొంతమంది గొడవ జరిగినప్పుడు ప్యానిక్ అవుతారు, రైట్? కొంతమంది ఇంట్లో సమస్యలు వచ్చినప్పుడు you have a problem in your house, then you will act logically. కొంతమంది ఎమోషనల్ అవుతారు, ఎమోషనల్, లాజికల్, అండ్ దెన్ పీస్ఫుల్, హ్యాపీ, హ్యాపీ. కొంతమంది ఫ్రస్ట్రేటెడ్ ఉంటారు, రైట్? సో ఎవ్రీ హ్యూమన్ హ్యాస్ డిఫరెంట్ క్యారెక్టరిస్టిక్స్. Every human has different characteristics basing upon the
Yes,
situation.
sir.
సిచ్యువేషన్ బట్టి ఆ క్యారెక్టరిస్టిక్స్ అన్ని బయటకు వస్తాయి కదా. సిచ్యువేషన్ బట్టి మీకు మీ ఫ్రెండ్కి మధ్య గొడవ జరిగింది. గొడవ జరిగినప్పుడు సమ్ పీపుల్ బిహేవ్ డిఫరెంట్లీ, సమ్ పీపుల్ బిహేవ్ డిఫరెంట్లీ. ఇట్ డిపెండ్స్ అపాన్ హౌ డిపెండ్స్ అపాన్ యువర్ క్యారెక్టరిస్టిక్, రైట్? సో సిచ్యువేషన్, హియర్ కమ్స్ ద సిచ్యువేషన్. ఒక మనిషి ఎలాంటి వాడు అనేది మనకి నార్మల్ టైమ్స్లో తెలియదు, ఆ సిచ్యువేషన్ వచ్చినప్పుడు తెలుస్తుంది. Situation. So situation brings your characteristic outside. Similarly, now let us come to the structure. Because I am relating human and a structure, the doctors of human are the real doctors, right? But we are also termed as doctors of structures only. I guess mana profession inka koncham better, because we are dealing with somebody who cannot talk, the structure cannot talk, whereas doctors are dealing with humans who can talk. They will go to the doctor only when they have pain. If you are having fever, or if you are having stomach pain, or if you have headache, or if you have some other pain, if you fall, or if you have something else, you go to the doctor and you talk to him, and then you tell him how are you feeling, మీకు ఎలా అనిపిస్తుందో చెప్తారు, డాక్టర్తో అంతా కమ్యూనికేట్ చేస్తారు. కానీ ఇక్కడికి వచ్చేసరికి స్ట్రక్చర్, ఇట్ విల్ నాట్ టాక్ అట్ ఆల్, బట్ స్టిల్ యూ హ్యావ్ టు నో వాట్ ఈస్ ద పెయిన్ దట్ ది స్ట్రక్చర్ ఈస్ అండర్గోయింగ్, రైట్? సో దట్ ఈస్ వై ఐ హ్యావ్ రిలేటెడ్ హ్యూమన్స్ అండ్ స్ట్రక్చర్స్, అండ్ వీఆర్ ద కామన్ వన్, వీఆర్ ద డాక్టర్స్. సో ఇప్పుడు సిచ్యువేషన్ బట్టి ఒక్కొక్క క్యారెక్టరిస్టిక్ బయటకు వస్తుంది. ఫర్ ఎగ్జాంపుల్, ఇన్ యువర్ హౌస్ యూ హ్యావ్ సమ్ ఫినాన్షియల్ ప్రాబ్లం ఏదో వచ్చింది. Some people, what will they do? Some people will panic. Some people will try to get debt, or they try to get credit from outside. Appul cheddamani chustaru dabbu kosam. Some people, what they do? Some people will save money. Okay, so it depends upon your character. Whether you are hardworking, or whether you are lazy. It depends upon you, it depends upon the individual, right? So situation batti, when there is a problem in the house, then a person inside you, a character inside you will come. Similarly, here also structure lo kuda a character బయటికి రావాలి అంటే, ఇక్కడ ఎలా అయితే నేను కొన్ని క్యారెక్టర్స్ మెన్షన్ చేశాను ఫర్ అ హ్యూమన్, లైక్ లాజికల్, హ్యాపీ, ఫ్రస్ట్రేటెడ్, పీస్ఫుల్, హార్డ్ వర్కింగ్, దీస్ ఆర్ ఆల్ ద క్యారెక్టరిస్టిక్స్, దీస్ ఆర్ ఆల్ ద ప్రాపర్టీస్. Similarly, material also has these properties. What are those properties? Elasticity, you have ductility, and then you have brittleness, right? And then you have plasticity, and then malleability, and then toughness, right? And then hardness, and the last one is the strength. So a material having these properties: elasticity, ductility, plasticity, malleability, brittleness, toughness, hardness, and strength. So these are the properties, mechanical properties of the materials. Now we are going to discuss about these properties in individually. First question, why are we discussing about mechanical properties is, in your AP ESET exam, this is going to be your first question in your engineering. You are going to get 2 marks from this topic. The topic is mechanical properties of materials. On this you are going to get 2 marks. So you have to carefully understand what are these properties, how are we going to determine these properties, how do you understand, what is the concept behind these properties. I hope everybody is clear till now.
Yes,
Everybody is clear
sir.
till now?
Yes, sir.
Yes,
Right.
sir.
So as humans have different properties, the properties will be coming out basing upon different situations. Materials also have different properties which I have mentioned here. These properties also will come during certain times. So when do these properties come? So any human can have all the properties. Can anybody be not jealous గా లేకుండా ఉండేవాడు, and wise గా ఉండేవాడు, wisdom, I'll call as wisdom, non jealous, wisdom, clever, peaceful, kind, ఇలాంటి క్వాలిటీస్, గుడ్ క్వాలిటీస్ అన్నీ ఒక మనిషిలో ఉండొచ్చా? ఒకటే మనిషిలో అన్ని గుడ్ క్వాలిటీస్ ఉంటాయా?
No, sir.
ఉండవు కదా.
No,
సో
sir.
ఎక్కడో దగ్గర మేబీ 80% గుడ్ అయినా ఎక్కడో దగ్గర సమ్ పర్సన్ మైట్ బి హ్యావింగ్ ఓకే ఇవన్నీ ఉన్నాయి, ఎక్కడో దగ్గర సెల్ఫిష్నెస్ ఉండొచ్చు, లేకపోతే సెల్ఫిష్నెస్ ఎక్కడో దగ్గర హీ మైట్ బి లిటిల్ నెగిటివ్ మైండ్ సెట్ ఉండొచ్చు. సో ఇవన్నీ గనక ఉండే మనిషిని ఏమంటాం? ఇఫ్ అ పర్సన్ ఈస్ హ్యావింగ్ ఆల్ గుడ్ క్యారెక్టరిస్టిక్స్, he is non-jealous, he is wise, he is clever, he is peaceful, he is kind, a person who has all these characteristics, what do you call that person as?
Intelligent. Intelligent, sir. Gentleman, intelligent.
He is called as God, right? No human has all these characteristics inbuilt in, all the good characteristics together no human will have. If a human is having all the good characteristics, then you call that one as a, according to me, I'll call him as God, because he has control on his emotions, he has wisdom, he is kind enough, he is clever, he is peaceful, he is happy. I think all these characteristics cannot be possessed in a human. This can be possessed in a hypothetical human who is called as God. So similarly, in a material also, all these characteristics cannot be possessed in a single material. Every material might have one characteristics, it might not have another characteristics. Are you all following? Right? So they will be having certain characteristics, they will not be having certain characteristics. So materials cannot possess all these characteristics together. A single material cannot have elasticity, a single material cannot have ductility, brittleness, all of these characteristics together. Okay? So if any material is having all these characteristics together, then that kind of material does not exist at all. Right? Following all of you?
Yes, sir.
Okay? So right, so materials first they are undergoing some load, some external load. So when a material is undergoing external load, what will the material try to do? The material will try to develop resistance develop చేయడానికి ట్రై చేస్తుంది. First we are going to discuss about property called as elasticity. So it tries to develop resistance. So how is this resistance being developed? So when an object is there, when you are applying external load, this load will try to deform this body. So what happens is, inside this body you have molecules, small molecules. So when you are applying load here, these molecules will give reaction in return in an opposite direction. Okay, so the internal molecules will start giving resistance to this load. So this resistance will be there till elasticity, till this resistance it can develop till it has a property called as elasticity. That means these molecules will try to give resistance till its elastic nature. Beyond its elastic nature, if you still apply the load, the body will undergo deformations. That means this body will become this much size, this body will undergo compression, right? So now I will explain the same concept in terms of a graph. So when a body is loaded, you have loading coming on the body. So this body has to start developing resistance. How is this resistance being developed? Is the molecules which are present inside the body will start giving resistance by not getting compressed. If the loading is beyond the elastic point, then the body will undergo deformation. It will come to this shape. So, if I draw a graph, imagine this is a graph between stress and strain. There is a point called A, this point is called E. Here E is the elastic limit. So, what you have done is you started loading this
సార్
object.
కనిపించట్లేదు.
Screen కనిపించట్లేదా?
గ్రాఫ్ కనిపించట్లేదు సార్.
Okay, right. I think now you can see the graph here.
Yes sir.
ఎస్ సార్.
Right.
ఎస్ సార్.
Stress and strain, there is a graph like this. This point is A, this point is the origin, this is the elastic limit. So, what I have done is, now we are discussing about elasticity. So, when I have applied the load before elastic limit, A వరకు నేను లోడ్ అప్లై చేశాను. A is before E. So, if I apply the load before E, what happens is, if you start unloading, that means if you start removing the load, నువ్వు లోడ్ రిమూవ్ చేసేసిన తర్వాత the graph will again come back to the same shape. It will trace back. Red line lo chudandi, same the graph will trace the same shape. It will come back to O again after removal of load. Okay, because you are loading the material within the elastic limit, after removal of load it is tracing back to the same shape OA వెళ్ళింది, మళ్ళీ AO కి రిటర్న్ అయ్యింది. సో దిస్ ఈస్ కాల్డ్ యాజ్ ఎలాస్టిసిటీ. If you load the same material after E, imagine you have loaded it up to B. Beyond elastic limit. Now what happens is, now the graph will not trace the same shape. Now the graph will start tracing a shape like this. That means it has undergone a certain level of strain, which is called as permanent set. Okay, so this is the difference between loading a point before elastic limit and loading a point after elastic limit. So elasticity, how is elasticity defined as? It is the property, elasticity is the property by virtue of which, it is the property of whom? Property of the material, by virtue of which a material deformed under the load is enabled to return to its original dimension, Okay, after removal of load. This property is called as elasticity. So the body will regain its original shape again. Following all of you?
Yes sir.
The body will regain its original shape again after removal of load. So if you load the same material after elastic limit, if you load it to B, it will not trace back the same shape of the graph, whereas the graph will be something like this. The graph will come down to BC. It will take the shape BC, where OC is the permanent set. Okay. So examples of elasticity, steel, aluminum, copper, concrete it is also a bit elastic only. Okay. it is considered, concrete is considered elastic within certain limits. Okay, there is some limits to it. Understood all of you?
Yes, sir.
Shall we move on to the next property? Shall I erase this?
Yes, sir.
Right. Now comes the next property is plasticity. Plasticity. Have you all taken down the definition?
Yes,
Plasticity
sir.
definition తీసుకున్నారు కదా? Right. So plasticity is the opposite. Plasticity is the opposite of elasticity. It is the opposite of elasticity. Okay. That means after removal of the load, it will not recover. It will not recover to its original shape. It will not come back to its original shape. Okay. They will behave like plasticity. They will behave like viscous liquid. This is very, very important. All of you take down this. Plasticity, the material will behave like a viscous liquid. Viscous liquid. What is this? Why are we calling it as viscous liquid? What is viscous liquid? Viscous liquid, you can take example of oil. Oil. You take an inclined plank. Take a plank. You pour oil in it. What happens to the oil? The oil will start flowing. The oil will start flowing. Even if you stop somewhere, మీరు మధ్యలో చేయి పెట్టి ఆపుదామని ట్రై చేసినా కూడా the oil will not stop. It will start continue. It will continue to flow again. Okay.
Yes, sir.
That means what is happening to oil? Oil is undergoing continuous deformation. It is undergoing continuous deformation. So when a material, if it is loaded beyond its elastic limit, what happens? It has a certain limit of regaining. But if you keep loading it continuously, certain limit వరకు మీరు అప్లై చేశారు. దిస్ ఈజ్ యువర్ ఎలాస్టిక్ లిమిట్ E. A వరకు బ్యాక్ వచ్చేస్తుంది. B, if you load it beyond E, that is if you load it B దగ్గర వరకు పర్మనెంట్ సెట్ వరకు వస్తుంది ఇలాగా. If you start loading even after B, what happens? The graph will take a straight line like this. So what is happening? Let me take this point as C, D. Why is this straight line coming? The straight line here, what is the straight line representing in this graph? Straight line is representing that there is no increase in stress, but there is a drastic increase in strain. Yes or no? There is limited or no increase in stress, but there is drastic increase in strain. I think మీరు ఎప్పుడైనా చాక్లెట్ కవర్స్ని స్ప్రెడ్ చేస్తూ చాక్లెట్ కవర్స్ని ఎక్స్పాన్షన్ ట్రై చేస్తూ ఉంటారు. మీరు చాక్లెట్ కవర్స్ని డ్యూరింగ్ యువర్ చైల్డ్హుడ్ you must have played with chocolate covers where you try to expand the chocolate cover. In the beginning, the chocolate cover will not expand. If you have not tried it, you try it now or tomorrow. You try to expand the chocolate cover initially it will not expand because it will start giving resistance, because you are loading it within its elastic limit. You somehow wants to expand it, and what you do is you still try to pull the chocolate cover. Suddenly the chocolate cover at some instant it will expand off. It will change, the length of the chocolate cover will expand. I think you have observed this. If you keep expanding it further, at certain point it will tear. Okay. So what is happening is up to certain point there is elastic limit where it will start giving resistance, but after certain point it will not give any resistance. Instead it will undergo permanent set. This is the permanent set of strain. If you keep loading it again, even if you don't load also, even if you load a minimum value also, the strain will be huge. It will start expanding and it will somewhere it will break, because the strain is not stopping. It is compared with a viscous liquid. Like how a viscous liquid will not stop. when it is flowing. Same in a similar manner, the material also, after it has crossed its elastic limit, even if you apply a minimum increase in stress, it will start expanding. That is why it is compared like a viscous liquid. So plasticity is the opposite of elasticity. It will not undergo any recovery after removal of load. Its behavior is something like a viscous liquid. Okay. Okay, na? So how do you define plasticity? Plasticity is the characteristics of a material. It is the characteristic of a material. What kind of characteristic? Which undergoes inelastic strain. Beyond inelastic strain, beyond those at elastic limit. You have to underline inelastic strain. Why are you calling it as inelastic strain? If you see here, before elastic limit also this material has undergone some strain. There is some strain value. If you see the graph here, there are certain strain values here also.
Yes, sir.
But after E, if you see, without any increase in stress, the strain is increasing. But if you see before E, there is some increase. Here it is sigma 1, here it is sigma 2. That means there is increase in stress by this much. Here the stress is sigma 3, here the stress is sigma 4. Okay, here the stress is sigma 5. Now after sigma 5, is there any increase in the graph? Is the graph going vertically or the graph is going horizontally? The graph is going horizontally. That means in this case the strain is increasing but the stress is not increasing. This zone is called as plastic zone. I hope all of you understood.
Yes, sir.
Okay.
Yes.
So plasticity is also useful. This property is also useful in designing. This property is also useful in designing structural members. I will tell you when the design topic comes how this plasticity property is used. Okay. Shall we go to the next property called ductility? Have you all
Yes, sir.
understood?
Yes, sir.
How do you find out this elastic property and plastic property? I think you must have done UTM, universal testing machine. You take a rod, you take a steel rod and you try to expand it. You try to apply pull. What happens to the material? After you apply pull, the steel rod will not be the same. It will take a shape like this. Yes or no?
Yes, sir.
So what is happening? Here the diameter is different. Here the diameter is different. That means it will undergo a failure called as cup cone failure. It will undergo a failure called as cup cone failure. It will undergo a failure something like this. The diameter here will be this much, but the diameter here will not be this much. It will reduce. సన్నగా అయిపోతుంది అన్నమాట అక్కడికి వచ్చిన తర్వాత, because you start pulling it, it will undergo expansion, because here when it comes here it will become thin and it will fail. Okay. So these tests, plasticity and elasticity, you do these tests in universal testing machine. The gauge length is taken as 5.65 root A. The gauge length. What do you mean by gauge length? Gauging means measuring. So length means the length in which the experimental measurements are taken. The gauge length. For example, if this is the length of the specimen that you are using, this much is the length of the specimen you are using, but you cannot determine the test results. టెస్ట్ రిజల్ట్స్ కోసం అని చెప్పి మనం మొత్తం లెంత్ వాడకూడదు. యూ షుడ్ టేక్ అ సర్టెన్ లెంత్ ఓన్లీ. దిస్ మచ్ లెంత్ ఓన్లీ యూ షుడ్ టేక్. దిస్ లెంత్ ఈజ్ హౌ మచ్? 5.65 root A. Following all of you. Because
Yes, sir.
after you do the test, you will find out the stress value and you will find out the strain value. Only when you know the stress and strain value, you can draw these graphs. Yes or no? So for calculation of stress and strain, you need areas. You need areas. For calculation of area, you need diameter, because the formula of area is pi by 4 diameter square. Yes or no? So initially if you take this as the diameter, but at the failure that is not the diameter is reducing here. Yes or no? Diameter is changing to diameter 1.
Yes, sir.
So that is why you have to take a certain length. Only ఈ length లో మాత్రమే మీరు measurements తీసుకోవాలి. That length is called as gauge length. This is also very very important. Give a heart to it. That gauge length is taken as, that is given by the formula 5.65 root A. Okay.
Okay,
Shall we
sir.
move on to the next property now?
Yes, sir.
Sir.
So the next property is ductility. Next property is ductility. So ductility is one of the characteristics of a material which will allow the material to be drawn into longitudinally thin wires. Longitudinally thin wires. That means ductility is a property which will allow the material, అంటే సాగదీయడానికి అలౌ చేస్తుంది అనమాట. దట్ మీన్స్ ఇఫ్ అ material is something like this, it can be pulled into a thin rope. When it is being pulled, it will become thin, right? So it allows the material to be pulled into a thin rope like this. Thin rope like this, longitudinally. Here I mentioned longitudinally. Okay, ductility is the property of a material. It is the property of the material which will allow the material to be drawn into longitudinally thin wires. Under the action of which force? Under the action of tensile force. Under the action of tensile force. Okay, following all of you? So during ductility what happens? Large deformations will occur. Large deformations before failure. Before failure you will see large deformation. See, initially this was the length of the material, but before failure what is the length of the material? Isn't it huge? So before failure the length will drastically increase. So you will see large deformations. Okay. So for a material to be ductile, ductility undali ante compulsory that material should have high degree of plasticity undali and high degree of strength. ఈ రెండు క్యారెక్టరిస్టిక్స్ కంపల్సరీగా ఉంటేనే ఆ మెటీరియల్ డక్టైల్ అవుతుంది. I hope all of you understood what is ductility is. Any material which can be drawn into thin wires, then you call that property as ductility. This is according to the definition, a simple definition. But when you talk technically, ductile material ki compulsoryga it should have high degree of plasticity undali. At the same time it should have high degree of strength. హై డిగ్రీ ఆఫ్ ప్లాస్టిసిటీ ఎందుకు ఉండాలి? హారిజాంటల్గా అది సాగాలి అంటే కంపల్సరీగా ప్లాస్టిక్ మెటీరియల్ అయి ఉండాలి. హై డిగ్రీ ఆఫ్ స్ట్రెంగ్త్ ఎందుకు ఉండాలి? బికాస్ వెన్ యూ ఆర్ పుల్లింగ్ ఇట్ ద మెటీరియల్ షుడ్ నాట్ బ్రేక్ ఎనీవేర్, ఇట్ షుడ్ నాట్ క్రాక్ ఎనీవేర్. సో దట్ ఈస్ వై యూ నీడ్ టు హ్యావ్ హై డిగ్రీ ఆఫ్ స్ట్రెంగ్త్ అండ్ ఆల్సో యూ షుడ్ హ్యావ్ హై డిగ్రీ ఆఫ్ ప్లాస్టిసిటీ. ఓకే, సో హౌ ఈజ్ డక్టిలిటీ మెజర్డ్? Ductility is measured. This is very very ఇందాక నేను చెప్పలేదు, I forgot to tell you. Elasticity is measured in terms of stress units only. What are the units of stress? Newton per meter square. Elasticity and plasticity both are measured in units of stress. Okay, important. You also make a note of it. I just forgot to tell you there. Both are measured in terms of stress only. Ductility is measured in terms of percentage elongation. It is measured in terms of percentage elongation. Following all of you?
Yes, sir.
Percentage elongation, or sometimes it can be measured in terms of percentage deduction in area. Okay, percentage reduction or deduction in area. Percentage reduction in area. Most of the time you will designate it in percentage elongation only. So how is ductility determined? Ductility is also determined by the UTM test only. UTM, universal testing machine, the same elongation test that you do for a rod, same thing you do. Okay, shall we move on to the next property?
Yes, sir.
The next property is brittleness. Next property is brittleness. So brittleness is exactly opposite of ductility. It is opposite of ductility, brittleness. So in ductile material it is expanding. Brittleness, it will not expand. What will happen? If you start increasing the load, it will suddenly break. Okay, so brittleness is a material which does not have ductility is called as brittleness. Okay, that means a ductile material, if you see the difference, if I draw the graph, stress strain curve, ductile material will fail somewhere here. The failure point is D. For a brittle material, the failure point is somewhere here only. This is the failure point. Following all of you? So that means this is the graph which is representing brittleness. This is the graph which is representing brittleness. This is the graph which is representing ductility. For a ductile material, it will have a huge deformation before failure, but for a brittle material, it will not undergo any deformation. It will stay still and suddenly it will fail. Okay, so ductile material will fail with a warning, whereas brittle material it will fail without warning. అంటే ప్రకాష్ రాజ్ లాగా అలా చూస్తూ ఓకే సిచ్యువేషన్ అంతా మన కంట్రోల్నే ఉంది అని అనిపిస్తుంది, కానీ సిచ్యువేషన్ మన కంట్రోల్ లేదు, సడన్లీ ఇట్ విల్ ఫెయిల్. సేమ్ థింగ్. సో బ్రిటిల్ మెటీరియల్ ఈజ్ నాట్ దట్ ఈజీ. యూ కెనాట్ స్టడీ the mindset of brittle material that easy, whereas you can study the mindset of ductile material, because ductile material is very flexible, very comfortable, right? Somebody like if you come for somebody like me, ఇప్పుడు మీకు సర్స్ లేపు నా దగ్గరికి వచ్చి యూ కెన్ స్టార్ట్ డిస్కసింగ్, యూ కెన్ ఆస్క్ డౌట్స్, యూ కెన్ ఆస్క్ అబౌట్ యువర్ career plans, you can start asking about your reset, anything you can come and discuss. But whereas if you cannot discuss the same thing with your HOD sir, right? HOD sir తల్లి అన్నీ మాట్లాడలేం కదా. సో దట్ ఈస్ బ్రిటిల్నెస్. Ductility, it is pretty flexible. Following or not, girls, all of you?
Yes,
So it will
sir.
fail without warning. He will suddenly start shouting on you. So that is without warning. It will fail without any warning. Ductility will fail with a warning. You will not see any deformation. No desirable deformation. No desirable deformation. Ante failure ayye mundu you will not see any kind of deformation. You still feel that okay, everything is fine. The situation is in our control only. Everything is fine anukuntamu, kakapothe the situation is not in our control, it will fail. Okay, that is brittleness. I hope all of you understood with respect to the graph also. Can you tell me what are the materials? Give me some examples of brittle materials. Cast iron, high carbon steel, high carbon steel. Next is concrete. Concrete is also brittle, right? Inka stone, glass, ఇంకా ఎనీ సిరమిక్ మెటీరియల్ అంటే టైల్స్, మనం ఇంట్లో వేసుకునే టైల్స్ కూడా బ్రేక్ అయిపోతాయి, సడన్గా క్రాక్ వచ్చేస్తుంది. సో దీస్ ఆర్ ఆల్ ఎగ్జాంపుల్స్ ఆఫ్ బ్రిటిల్ మెటీరియల్. ఓకే, రైట్, we will move on to the next one.
Yes, sir.
Next one is malleability. I hope all of you are well aware of the term called mallet, sutti. Mallet at a sutti, you must have seen something like this, hammer kind of thing, malleability. A mallet is called this. So what is malleability? When you take a thick surface, when you start hitting with this mallet, this will become a thin surface, like it will expand and it will become thin like this. Yes or no? It will become thin like this. So what is happening? When you are hammering with this mallet, this material is undergoing expansion in all directions. That means this
సార్ ఎవరికి క్లాసులు ఆన్ అవ్వట్లేదు సార్, బ్యాక్ వచ్చేస్తున్నాయి.
back
నెట్
వస్తుందా?
అయిపోయింది సార్. నెట్ కాదు, బ్యాక్ వచ్చేస్తున్నాయి సార్. సార్ ఎవరికి ఆన్ అవ్వట్లేదు.
ఓకే ఓకే, జస్ట్ సెకండ్.
బ్లర్ అయిపోతుంది సార్.
ఎర్ర అయిపోతుంది సార్.
సార్ సిగ్నల్స్ లేవు సార్ ఇక్కడ.
మీ దగ్గర సిగ్నల్ ఇష్యూ ఉన్నట్టుంది.
ఎస్ సార్.
అవును సార్, ఎవరికి రావట్లేదు.
సిగ్నల్ ఒకసారి చెక్ చేసుకుంటే బెటర్ ఏమో.
సార్ ఒక పాయింట్ లేదు సార్.
ఏంటి?
ఇప్పటి వరకు వచ్చింది సార్, ఇప్పుడే ఆగిపోయింది.
అదే మీకు సిగ్నల్ లేనట్టుంది. అయితే మ్యాల్యబిలిటీ వరకు వచ్చిందా?
మధ్యలో ఒకటి ఎగిరిపోయింది సార్.
ఓకే,
బ్రిటిల్నెస్ రాలేదు సార్.
సార్ మాకు డక్టిలిటీ వరకే వచ్చింది సార్, తర్వాత ఆగిపోయింది.
బ్రిటిల్నెస్ ఆగిందా?
ఎస్ సార్.